Hey guys, Edward here from Edward79, the Mixed Content Creator. The vertical line test is one of those things that, although it might not seem very important in the sphere of math, it's actually a pretty important thing to know when it comes to algebra, especially if you're dealing with whether a graph curve is of a function or not. So this is the vertical line test explained. So first, background. What does a given graph curve need to have for it to be a function? Well, only one thing, really. A vertical line, hence the name vertical line test, must only cut, or in other words, intersect, the graph curve once and only once at any given point. If a vertical line cuts the graph curve once, the curve passes the vertical line test and is a function. However, if that vertical line cuts the graph curve more than once at any point, the curve doesn't pass and isn't a function. Want to see that written out in some examples? Here we go.
To start with, let's take a look at this one. You can clearly see it's a graph curve, but is it a function? Let's find out. Using the vertical line test, we can find any point at which this vertical line cuts the graph more than once. As I move this vertical line across the graph, we will find any point at which the vertical line cuts the graph more than once. And once. Judging by what you saw, when the vertical line was moved across the graph, you could see that there were absolutely no points at which the vertical line cut the graph more than once. That's a good thing. But you also may have noticed something. There are some areas of the graph in which the vertical line didn't cut the graph curve at all, and that's totally okay, as that will not cause a graph to fail the vertical line test. But the big thing is that on this entire graph, there were no points at which the vertical line cut the graph curve more than once. That means this graph passes the vertical line test and is a graph of a function.
But now that you might think about it, why does the vertical line must cut the graph only once for that graph to be a function? Well, in a function in the context of algebra, you must get one output value for every input value you put in. Or in other words, the number of output values in a function must be equal to the number of input values. If a graph is cut by the vertical line only once, that means for every one input value, there's one output value. That's a function. On the contrary, if a vertical line cuts the graph more than once, then that means there are multiple output values for every one input value. And because I said earlier that functions must have only one output value for every input value, something that gives multiple output values for one input value isn't a function. So with that out of the way, let's look at more examples.
So this is another example of a graph that could, keyword could, be a function. I never said it was, but let's do the vertical line test to make sure it is a function. Okay, so far no problems. Oh, and we have problems. Because at the point where the vertical line is right now, how that vertical line intersects this graph curve not once, not even twice, but 3 times. Now, I also have to clear up something here. Here. A vertical line intersecting a graph have multiple times to fail the vertical line test doesn't have to be throughout the graph. If even at one point does a vertical line intersect the graph more than once, then that graph as a whole fails the vertical line test. Here, I've already marked a spot where the vertical line intersects the graph 3 times. So this graph fails the vertical line test hard and is not the graph of a function. But what about this one? Surely this graph will be the graph of a function, right? Right? Actually, no. Not even that far into the graph, and we already see a problem. Because the point where the vertical line is right now, that vertical line intersects the graph 2 times. And even though it's just 2 times 2 is still 2 times is still 1 time too many, and so this graph is not of a function. Okay, so what about this one? Surely after 2 graphs that failed the vertical line test and are not graphs of functions, this one has to be the graph of a function, right? I'm pretty sure, but it's best to use the vertical line test to know for sure. Oh, and if you're wondering why I have to move the vertical line across the entire graph, it's because there are spots in which a vertical line would cut the graph more than once that you might not get if you do not move the vertical line across the entire graph. Obviously, I'm doing this digitally, but if you're doing paper, do this in your you're kind of forced to do this in your head. Anyway, did you notice something? Let me move this something while I was talking. Let me move this vertical line across the graph again. Now do you see it? Yup. There is no point at which the vertical line cuts the graph more than once. So, good news, this graph passes the vertical line test and is a graph of a function. Now this last one. Function or not a function? Let's find out using the vertical line test. Test to then move it across the graph. Like I said earlier, there are areas of the graph at which the vertical line does not cut, quote unquote, cut through the curve. And also, like I said earlier, that is completely fine. But now we have problems. Because throughout this entire graph, there is almost no point at which the vertical line doesn't cut the graph at least twice. 1, 2. And even if you were to reposition the vertical line, there'd still be areas where the vertical line cuts the graph twice. So, in essence, that means this circle curve fails the vertical line test hard, and this curve is not a function.
So, in essence, The idea I'm trying to get to is that if presented with a graph and you need to find out if that graph is of a function or not, use the vertical line test. If a vertical line cuts the graph once, or sometimes not at all at some points, the graph is of a function, because the graph being cut only once means there's only one output value for every input value. On the other hand, if at any point a vertical line will cut the graph more than once, the graph does not pass the vertical line test and is not the graph of a function, as a vertical line, quote unquote, cutting the graph more than once at any point means that there are multiple output values for one input value. So there you have it, the vertical line test explained. We hope you enjoyed this video. Like, share, and subscribe if you want to, and as always, I'll see you in the next video. Edward here from Edward279, the Mixed Content Creator, signing out.